Hello and welcome to this lecture where you are going to learn the basic intuition about two other tracking algorithms. The first one is KCF, kernel correlation filters, which is a fast algorithm. However, it doesn't perform very well, especially in fast videos. And one of the most common problems is when the bounding box loses the object, as you can see here and here. KCF is an extension of MIL algorithm that presents some improvements and considers that in the MIL algorithm there are many overlapping regions, as you can see here. One box can be created above others. So, KCF aims to solve this problem. So, this image shows an example of how it works. We have here the first frame, which is the initialization or the definition of the object to be detected. When working with videos, we use the first frame to select the object we want to track. Let's assume that we selected this red frame here. For example, the goal is to track this face. So, the algorithm applies a concept called particle filter, as you can read here, and two more large bounding boxes are created to cover a larger part of the image. Here, the blue one, and here the green one. Next, from frame 2 to frame 3, the larger rectangle is used, the green one, and some mathematical calculations are made to adjust the frame in the central part of the face. As you can read here, the filter is updated. Then, from frame 4 to frame 5, the blue filter is updated to the center position of the face. Then, in the next frame, the same process is also made, now considering the red bounding box. After finishing the first update of all filters, see that the size of the larger filter has decreased slightly, the green one. See here in the original image that the border is next to this frame at the background, and here the position is quite different. So it was adjusted to the object. On the other side, you can see that the bounding box has been moved, here where I am pointing the mouse. The goal of the algorithm is to make several adjustments in these bounding boxes in order to circle the objects and be able to detect it. The larger frames are important to detect changes in the scale or the size of the object. For example, if in one frame the object is smaller and in the next frame the object increases in size, like a person approaching the camera. Now let's go to the basic understanding of the CSRT algorithm, which means discriminative correlation filter with channel and spatial reliability. It is more accurate than KCF, but is slower. This image shows the steps of the algorithm. In the first box here, we select the object we want to track, for example, only the person's head. See here this term patch, which is widely used in computer vision and is related to the information that was selected from the image, information about the pixels of the image. Then, in step number 2, a discriminative filter is created and the Hog histogram of oriented gradients technique will be used, and it will extract the most important information from the image and discards everything else. ROG will also identify the edges and corners of the image to discover the shape. For example, the head is shaped like a circle. In the third step, a random Markov test is applied, which is a mathematical concept, to predict the next image. See here that we have the same shape as the image, as if it were the person's next movement. In this step, probabilities will be generated to indicate the person's movement. For example, if the person turns his face to the other side, in this part here, that the prediction will be made in order to verify if the movement is of this person so that the algorithm continues tracking. Finally, in step number 4, a confidence map is used. In the image, we have only the object with a mask, and at the ends, we have the complete object to be tracked. As you have noticed, this is a more complex algorithm that uses several computer graphics techniques, and the purpose of this lecture is only to present an overview. If you want to know more details, you can read this article for more information. In the next lecture, you are going to learn some more algorithms. See you there!